Hello, class. We're going to have a quick video just on C++ class design. What are some of the principles that we need to employ and keep at the forefront of our strategy when we are developing a class? So we'll look into that real quick, and then I've got just a couple other miscellaneous topics that I'll throw into this. Now, essentially, if we have to create a class from scratch, the book goes into this in great length and is a really good read that you must read. Class design really comes down to nouns and verbs. So, what does that mean? Well, if we have some nouns over here and some verbs over here, we try and let's describe something just easy. Let's say a car. Well, if we were to sit down over an iced tea and just talk about cars, part of that conversation would easily be categorized into nouns and verbs related to those cars. Well, we can take those nouns and verbs and create a class from it. Here's a good example. If we said, well, a car typically has these attributes. I mean, a car would have a color. Okay, that's a noun. It would have a make and model. Those are nouns. Let me spell it right there. It will have wheels. It will have doors. All of these are nouns. And if we put them over on the noun side, we will see that these will directly translate to private member variables. Now let's look at the verbs. If we're talking about cars, we might say, well, a car can accelerate. A car could also brake. And that is to apply the brakes to slow down, not to B-R-E-A-K, brake and not run anymore. A car could certainly crash, couldn't it? A car might have a certain appraised value. Okay, well, that's a noun. We'll put that over here. A car might be traded in. Well, that's a verb. We could put that here. So you kind of get the idea here. Our nouns and our verbs make this very neatly defined list that we can then translate into our class. Now, the general model for this is, and let me go to a blue color here, oops, is that our nouns then will all translate and become private member variables. And then the verbs will all sort of translate and become public methods. Now, sometimes, of course, you'll have to groom your discussion. You may come up with 1 million nouns and 25 verbs. And of course, you can't have a class with 1 million private member variables in it. The developers that use your code would just revolt. So you will have to do some grooming and keep them rational and sane, and just don't go crazy. Now, based on kind of this structure, it's going to be very easy then for us to craft a class based on this. We could first start with our UML, which would be profoundly easy to make now that we've got this list. Our UML would just have minus signs in front of all of these for private and plus signs in front of all of these for public. And we could just start to then flesh it out. So that's one of the first things about designing a class, is getting our nouns and our verbs straight and just seeing how those translate. All right. Let's see, the next thing I wanted to talk about was private member functions. Now, so far in our coding, all of our class methods have been public. And that's, of course, for a reason, because it serves as the interface. Only public methods can be invoked outside the class. So that serves as the conduit by which we use authorized methods to manipulate this data. The data as a concept is always closely protected. It is hidden from the quote public, and that's why we have to use our authorized interface methods to get to that data. Sometimes though, if we don't need to have a public method because we're never going to call it outside of the class, that might serve rise to a strategy to make a private member method. You can have a private member function. And it sort of becomes a for internal use only type of a function then. So, what might that mean? Well, a good one might be, well, let's say that we have a class that we have to always be aware of if the state of it is valid or not, okay? If we had a private member variable called valid, and your program this week is references this a little bit, we would need a method that's going to go through and look at our private member variables and make sure that they're all valid, and then set that Boolean valid to either true or false. Now, we would never envision needing to call this method publicly. In our main program, we would never really need to invoke, the object name and then call, validate on it, because it's going to only be used by public methods. So if a public method, if it needs to do just some kind of a routine utility, maybe a routine function, and you don't want to keep doing it over and over, and you never ever need to call it publicly in main, well then, yeah, just make it a private member method. And that'll just more closely keep our class organized with respect to security. Anything that doesn't need to be public shouldn't be public. Go ahead and make it private, especially if it's something that you're not going to need in main. This sort of follows the same programming strategy as in our date class work in the last module. That date class had an internal private array that just stored some data, some month names. And it's sort of the same idea. We don't need those month names in main. We just need those for internal use only, so we can serve up the right string. So sort of the same concept here. So that's what private member methods will do for us. Let's see, a few more class design principles. One is completeness. So, well, what does this mean? When we design a class, it should be complete. So that means it needs to have all of the setters and getters. It needs to have a wide range of constructors. And by wide range, of course, I mean a default constructor, a parameterized constructor, or a partial constructor, a good mix of those, just to be able to handle whatever gets thrown at the class. Also in the sense of completeness, the class needs to be able to validate the data being given it. So our various validations all belong in the class so that it serves as a black box. You don't necessarily know what goes on inside, but you know that if you feed it some data, you're going to get some results. If you call a getter or a setter, you're going to get some results. If you get a constructor thrown in, the black box idea really lends to this idea of class completeness. Now, with our class completeness, validations, they need to occur. And of course, since we're developing for developers now at this level, using an error log is a very common thing. We will want to make sure that our error messages are just very short, they're clear. We don't need to go through a whole lot of drama. And importantly, as far as completeness goes, we would not want to have interactivity in our class. We wouldn't want to have a whole lot of interactivity. And why is that? Well, let's say that we try and send a bad value to a constructor and it kicks it out saying, nope, this is a bad value. I can't create the object. Well, it's the job of the main program to figure that out and then give it some valid data. It's not the job of the class to go ahead and say, okay, well, give me another piece of data and let's try that. Give me another piece then and let's try that, and keep going until we have a successful object build. No, a class doesn't do that. A class just says it's going to look at the data it was given and just say yes or no. If yes, then it's going to build the object or do whatever manipulation we need. If no, we just reject it, give a message to the developer, and that object is not built or manipulated, whatever we're trying to do with it. So remember that, minimize interactivity. So this then begs the question, well, if you are going to ask the user to enter some input from the console, and that's eventually going to be ported over into an object, well, where would that data validation happen? And you'd still do it with the class, but the interactive portion of that belongs in main, saying, oh, nope, you messed up again, let's try it again, give me another value. We're going to try and use that to create this object in a properly defined, hopefully a properly defined constructor. So minimize your activity there. You want to be able to have your class be completely contained, okay? Meaning it is going to just deal with the subject at hand. If you're creating a class for a goat, you don't need to care about any other farm animals, just the goat. So the other idea is containment. And another way to kind of look at this is, our classes should be single purpose. So if you're creating a class and it's got a method in it that is cooking everything under the sun, including the kitchen sink, and interacting with the user and narrating a program, that's going to be an ineffective programming strategy, because all our class needs to do is define the object, define the operations on those objects, and that's it. You wouldn't want to have a class that is going to, say, manufacture several objects together and put them into a container, because that's not what a class does. A class just cares about one object, its data, and the methods. That's it. If you want to talk about containers for objects, that all goes into your main program. If you want to have maybe a very lengthy input process, all of that belongs in main, because all the object cares about, all the class cares about, is getting some data fed to it, putting that through some constructors to get these objects built. So single purpose, narrow focus is another good way to to consider that too. Now, also, kind of as part of completeness and containment, you do want to have a basic output function, just a very simple line-based output function, so that you can do checking as you go on, as your code. You can also then use that for some of your base output. Now, in general, we do stick to simple output in our classes. And that's because, well, if a developer later says, well, I want to take that and improve on it, well, they certainly can. When we get to inheritance and all of that, they'll be actually able to overwrite your basic print method with one of their own. And redefining a base function in inheritance is very easy. And that then lets the developer just develop their own style or function for the output that they need. Let's see here. Yeah, so those are some of the best design principles, I think, to get us started. So keep these in mind. And again, you will want to keep your classes contained, neat, and easy. Don't make them solve world hunger. All they need to do is create and manipulate the objects. And that's it. So keep these in mind when we're starting our OOP journey, and it'll definitely help you as we go on. All right, thanks everybody.